isometric drawing and things of that nature to help you visualize, you can use that. Okay. Clay, stuff of that nature. I'll allow an hour and a half. Well, I think this one actually, we ought to push this out just so you don't feel too stressed. I'll give you 2 hours for the test. I don't think you'll need it. In fact, I think if you come in totally prepared for this test, you're probably looking at about 30 to 40 minutes. But just in case you start second guessing yourself, I'd like you to have the option of removing your correct work and putting wrong stuff on there. Yeah. Test can be composed of 3 parts. The first part is where I'm going to test your knowledge of definitions. It will be a picking or matching section. So there will be a list of definitions and a list of terms, and you need to match them up. Okay. Following that, I will have 3 short essay questions. Those first two sections count for about 35 to 40% of the test, and you'll move into the final portion, which is all applied. That will account for the last 60 to 65% of the test. Okay, let's go. That's kind of the gist of the general consensus of it. Now, one other thing on the general. Chapters 13, 14, and 15 are all fair game, except for developments, because that is not, I only do intersections, visibility, and developments if we have time, and we got time this year. So there will be no developments on the test. We'll leave that to the drawing, but the intersections and visibility portion that we covered out of 15 will be on the test. All right, that's kind of the general consensus. Let's go back to the picking and definitions. What kind of definitions should you know? Okay. This whole process of solving the problems, 13, 14, and 15 are solving the problems of orthographic projection that were introduced in chapters 10, 16 for sections. That whole problem, we saw that, we can't deal with dihedral angles, we can't deal with inclined planes, we can't deal with oblique planes. For you to deal with them, first you have to recognize them. Okay, so know the definitions of your planes. What's the definition of normal plane? Anybody know?
Plane on X, Y, or Z axis.
No. Normal plane. Remember, normal means you are looking perpendicular. So, true size and shape in one view.
An edge on the other.
Edge and all adjacents. Got to be able to identify those. What's true size and shape on a drawing? Inclined plane, what's the definition of that?
Size and shape.
Edge view in one view, foreshortened in all adjacents. What's an oblique definition?
Foreshortened in all views.
Yep, foreshortened in all views. If you can't recognize those planes, then it's pretty tough to know how to solve them. Okay, so that's the first step, is understanding those. Now, we've already tested over 10 and 16, haven't we?
Yeah.
Those handled normal planes very nicely. Guess which kind of planes we're going to deal with this time?
Everything else.
Everything except for normal planes. So know those definitions. Know the definition of what an auxiliary view is. Anybody remember that one? There you you go. Say it loud, please, Lisa.
It's a view projected, any of the place, or any views except for one of the normal 6 views.
There you go. Okay, so know that definition. We're dealing with dihedrals. What's that definition?
Where two planes intersect.
Yeah, the angle formed by the intersection of two planes. What's the definition of visibility?
Turning those closest to the line.
Yeah, the process of identifying which objects are closer or further away from you. Intersections. Yeah, many times in industry we'll call this clashes. We look for clashes, or items that intersect that shouldn't intersect, or should intersect. All structures will go through, except, you know, these little widgets we're drawing, are kind of mechanical wise, we don't have a lot of clashes in those, but when we have any mating parts, which is mixed objects, as we have machines or buildings, where we have many, many objects that are interfacing with each other, we've got to deal with clashes or intersections. When we put that thing together, we want to make sure that is okay. What else on inner definitions did we deal
Height
with?
auxiliary, definitely with auxiliary.
Yeah, that's actually something we do need. Okay? So we had some auxiliary definitions that are specific to it. We had a height, width, and depth auxiliary. Remember how you figure those out? It's called the auxiliary view from the, if it's rotated from a view that is missing that dimension. So like the first one is height. What view is the only view that's missing height out of our 3 principal views? Front, top, right. Top. So that would be an auxiliary view rotated off of the top view. We also add on that primary, secondary, tertiary. Keep in mind for inclined planes and dihedral angles, well, inclined planes certainly only need a primary auxiliary view. Dihedrals, most of the time, only need a primary, but it could go to a secondary. Obliques, now that you have a shortcut, go to a secondary view. So we had, keep in mind with the obliques, we had another item called a strike line that removed one of our rotations. What would be the definition of a strike line?
A line
Close.
parallel to the border.
Yeah. An imaginary line interjected onto a plane to aid in solving Law 1. I can't think of any others. Are there any more definitions out there that we hit?
Law 1, 2, and 3.
What's that?
Law 1, 2, and 3.
That's the next section. Laws 1, 2, and 3 will not be in the picky area.
Well, that was easy.
Any other definitions you folks are confused on? All right, with that said, let's move to the short essay section.
Piercing point.
What's that?
Piercing point.
Pierce points. Yeah, where something clashes or where items intersect. That's really, I don't know that I'll define that. Short essay, there's 3 of them. What do you think these might be?
The 3 laws.
The 3 laws, how to use them.
Yes. Folks, this ought to be a gimme. Okay, but I will tell you straight up, I am going to be very picky on this short essay because those statements, those 3 laws of descriptive geometry have been looked over, picked over by many people, and it's been shortened, I think, as far as it can be, but it's important, the individual terms in there. On law 1, a line appears true length in the viewing plane parallel to it. I mean, that pretty much states it out. If you were doing law 2 and you put a line appears as a point, that's going to be wrong. Because a line doesn't appear as a point. A true length line appears as a point in the viewing plane perpendicular to it. So in essence, it's really a memorization drill. But we do have to move from the memorization portion to the application portion. That will be your short essay. After that, we will be moving to the application process. Now, before I leave the short essay, is there any questions on that? Okay. Now, when we move to the application portion, it's going to consist of 3 or 4 objects that will be very similar to your worksheets. And this counts worksheets 1 all the way through 11. Remember, 1 was projecting points, 2 was projecting lines, sheet 3 was projecting true length lines, sheet 4 was projecting inclined planes, 5 was oblique planes, I think 6 we went back to inclines. I didn't give you sheet 7. Can't remember what 8 was. That's dihedral, right? Oh, no, 8 was the applied problem, I believe, wasn't it? The pipe and the hopper?
Yeah.
Okay. And then we had 9 for a dihedral, and then you got 2 more that were separate from that, where you had intersections and visibilities on lines or pipes, right? We use the center line of pipes to represent lines, or lines to represent center line of pipes. And we also had planes intersected by them. By the way, I got all the worksheets back I've got, and I was missing some, so some of you still have them out there. I would suggest you get those in so I can get them critiqued for you in the back, and you can use those to study with. Those items there, they're going to be worth around 10 points each, so I figure that's around 30%. After that, I'm going to have 2 figures, and I will provide the complete multi-view description. Front, top, right, or whatever is needed. You will then have to project certain portions off of these. Okay. So expect your 3: inclined planes, oblique planes, dihedral angles. Expect those. If you don't, you will be surprised. That would wrap up the test. These will be done in a manual sense, but like I said, to aid you in visualization, if you wish to get some clay or use your computer for that, that is fine with me. I will also, just so you know, because one of the one of the devices is a little bit different. I've drawn the isometric of it, and I will have it up on the projector for the test. So that will aid you in visualizing that one item. In essence, that's my test review. At this point, let's give you a chance to, is there anything on your worksheets that was confusing or you're just not sure of? Would you like me to do anything on that?
On the bottom, you look at, it's on the wrong way.
Here on number 10.
DC is on the top of one of them. Last one said X is on top of both. I think,
What do you ask?
You got it.
number 10.
Oh,
Are you? I'll wait till
it's got both of them clean.
Okay, we can do
8, 9, and maybe that's this. It was 10, 9, 11, and then 11. You turn it in? You don't have it on? Okay, just a moment. Yeah. Well, if you want all.
Well, I'd like those more information.
Okay, number 10.
Maybe my lines aren't exactly. Let me see.
And this was a pretty common thing when I did these. I don't know that people really kind of understood the directions. So on number 10, what were we doing on this one? Keep in mind, let's read the instructions first. Find the point where line XY pierces plane ABCD. So that's an intersection problem, right there. Locate the point in all views. Then establish visibility. Those are two different things. Okay? Now, I don't have my key here, but in essence, what you've got on this, and I'll just kind of sketch it. So I have a full line that sits between these two views. And then what I then do is you're going to do a strike line. I think many of you did. So you went through a strike line parallel, something of this nature, and then that came up and hit something like here. That gave us the rotation angle for law 2. Okay? Because in essence, we need to see the plane on edge to determine intersections. So what we end up with over there is we have something like this, where this would be y, x, and then I have D, B with A and C somewhere in here. Okay. Now, to determine the clash or the intersection, we grab the point right here. Okay. Because if it's going to intersect, it's going to intersect at that point. Now, we don't really know that that intersects at that point. Okay. Keep that in mind. At this point, we don't know that. Because you could be sitting here looking at this thing on edge, and this line is back here or up here. Or it could be right through it. We don't really know. Not from this view. Not from this view, not from this view. But with a little analyzation, we can figure that out given this. So we know if it's going to intersect, it's going to intersect at the point shown in the edge view. Then you project that back. So we come back and project it back. And if you hit, now I'm looking at a point on XY because that's the line. I come back and I hit XY, I think most of us, we hit right around this area. If I hit inside plane ABCD, they intersect at that point. If I were to hit XY anywhere out here or anywhere down here, they don't intersect. Okay, that's how you tell them. This is what we call the Pierce point. So I found it here in this view. I would then project that down to this view, and there's also the Pierce point. Now, that tells us that they do intersect, but it only tells us half the story. We don't know if it intersects going into the page like this or coming out of the page like this. That is what visibility is about. So at that point, I start looking at other conditions, and on this one, I would look at this point right here. Now, if what I'm going to look at is line CD and line XY. So I'm isolating and only looking at two lines. And I project that down. Now I hit XY before I hit CD, which sits down here. So you want to do some vertex labeling, and so you know where things are. Okay, now when I project down, since I hit XY first, that tells me in this view, XY is on top. Okay, so it's only telling me about this. Then I go look at the other side. Now, this should be something that's really only a check, because I know XY is over CD here, and I know they intersect here, so therefore this one has to be AB on top, if this is a real condition, but we want to check it. So project that down, and you hit AB first. So here, AB is on top. Now that kind of tells the whole condition, doesn't it? I'm coming in at an angle, I pierce it here, and I'm going underneath here with pipe XY. Now, that's good for this view. That tells me this condition, but it's still, we don't know the angles or anything. We then come down to this view, and we need to establish visibility here also. So here, I'll look at this point. Now I'm looking at line BC and XY. I project that up. I hit BC first. Let's see, no I don't. I hit XY right here before BC up here. So therefore, XY has to be on top in this view. Now it's piercing, so this one had better come up where it's underneath line AD. And if you look at this point, project it back up, yes, you hit AD before XY, so AD is on top in that view. So in essence, really what you're trying to do here is figure out the conditions that are going on so that you more fully understand the geometric location of these items in relationship to each other. Okay. So keep in mind, this is intersections. This stuff right here is considered what we call visibility. Are there any other worksheets you would like to look at? Got him, Declan? Maybe, maybe not. Any you want to see?
This is the one on the screen.
Okay. Yes, John.
Page 8, the copper.
You know what? I never have worked this one other than in my office with a few of you, so why don't I work this one real quick? a fold line in between these two. Now, in essence, what we're looking at here, there's really kind of two ways to solve this. And this is the first time I've seen one of the ways, and I got to credit Majid for this. He came up with this method, and I can't find a hole in it, and I worked it twice and got the exact same solution both ways. I'll show you the way I normally have always dealt with this, and then we'll go back and maybe look at the other one also. It's valid in my mind also at this point. All right, so we drew this. We're trying to find out what's the distance from where this pipe is and point A, which sits here. Now, to do that, we've got to look down the center of the pipe. Okay, so we're going to take that and rotate it such that when I see that pipe, I'm going to look right down the center line of it. Now, I should be able to see at that point, point A, somewhere around here. And then I can measure that, and that will be the shortest distance I will see on those two items together. So in essence, to get to point view, okay, what do I have to do of that? I've got to do laws 1 and 2, right? First, I need to find true length. And I don't see true length here, because this is not parallel to that fold line, therefore this is foreshortening. This one's not parallel to that fold line, this is foreshortening. So first thing I've got to do is I've got to get true length. Now, when you're dealing with a pipe, and just file this one away in your memory banks, never deal with the edges of them. Always deal with the center line. Because if we've got this, if you deal with an edge and you rotate it, you don't know where that point is on the edge of that thing because it's circular surface. You have no datums on it. You do have a datum on the center line though, so no matter how that pipe is rotated, if you're dealing on the center, you will see it right. You can always draw a little circle that's equal to the diameter of the pipe when you get to the point view, if you really need that portion of it. So what I would suggest you do on stuff like this is I'm going to define a line segment of this pipe. Okay? And I'll just come in on the center line right with points B, C. Now keep in mind, if you're doing this in real life, all you got to do is just grab any pipe center line and just define a line segment of it. Okay? Just define where that center is. Now, if you project those through, this thing, since it's a worksheet, it's already set up for you. There's BC also. First thing I've got to do is get true length. Okay, and I may not be totally accurate here, but let's give it a shot. So I'll draw